And I'm here to talk about phase shifting. With phase, it is really the time relation between two or more sine waves. They usually coexist in degrees denoted by 0, so that usually means that they either come in within like the one complete cycle of a wave, the half cycle of a wave, or quarter, and they designate between 360 degrees, 180, 90 degrees, and it can get smaller beyond that. And it is usually dependent, the degree of the shifting depends on the time gap. So say if like you have one sine wave, the relation between them are like about 2 milliseconds, it would be a nearly unnoticeable change compared to a time relationship of a whole complete second. You would be able to noticeably hear the difference in the second phase shift versus the first one. And complex waveforms, since they could tend to have multiple different frequencies, can also have a varying degree of phase shift on their own, especially with each frequency. When mixing, most times you want to make sure that phase is not, how you say, about interfering with the sound and audio. But in some cases, there are some phases that technically work out well. An example could be, well, example could be a song. Which song? Here's one song that comes from one of my favorite artists that uses a delay as a telling show of phase shifting. I hate ads. And you'll notice when he starts screaming, that you'll hear a constant echo. With the right amount of phase shifting between frequencies and among the complex waveforms, you can emulate echoes pretty easily. And that's what Kendrick uses in his first part of his song. Now, with the problems, of course, that derive from phase shifting, like I said before, you'll get a means of interference with the recording itself, and you could expect different alterations in tone and coloration of the sound. And it also states that when they're phase shifted invertedly, they will end up causing themselves to cancel out of each other, as it says, and it can cause level attenuation. And it could, and even in many cases, if to the point where it's exact, it could result in like near complete silence. And so here's an example of a waveform being more so with inverted in a phase pattern. This is what you'll tend to see from snares, because with snares they have technically a positive and a negative kind of area with them between the top and bottom of the instrument itself every time you hit a drum. And usually what you would need to do is you need to alter the way that the shifting is made by the sound of the drum in order to get that true full sound among the two mics that you would need. Otherwise, the sound would be lost on one side or the other. And phase shifting can also be done with guitars as well, especially when you have like a lead guitar or sort of like a main guitar and they go on similar parts in some songs, that you can catch phasing as well. And sadly, it's not always audible in the obvious sense. There are times where it's more unnoticeable, and you'd have to sit and you'd have to kind of look for it. And when you're mixing, if you're doing something sort of like mix down, that's usually where you would find problems of phase, given the nature of the mixing and how you're processing and going about it. And of course, here are some examples like short delays. You can use equalizers. You can also use conversions from different outboard gears. And these are obviously the main reasons where you would find problems and such. And of course, with one trick that is explained in the textbook is called the Haas effect or Haas trick, in which what they usually do is they tend to have the original signal panned to one extreme, and while the other little kind of ghost copy of said signal is panned on the other. This tends to usually be a kind of go-to for me, especially in trying to fix any phase shifting. I would usually try and pan it and see how far I may need to pan, or how little does a pan need. But this is usually done between mono tracks. And yeah, that's my presentation on phase shifting.